Hello, welcome to week 9 to this discussion board of failure to comply. So let's jump into it, shall we? The background information of this problem is the probability of recovery from a flu outbreak in a country is 93%. A town reports that 19 out of 20 people recovered. Does this town have a higher recovery rate than the rest of the nation? Enough to reject the null hypothesis given alpha equals 0.05? What if all 20 townspeople recovered? What is the smallest sample size necessary to reject the null hypothesis? Out of this sample size, how many successes are required for alpha observed to be less than or equal to alpha? Well, let's see. The important information to pull out of this problem is that 93% probability of success in the nation, 19 out of 20 townspeople recovered or succeeded, we shall say. And then the null hypothesis of H is we're trying to reject this. So we're trying to find out if the town actually doesn't have a higher recovery rate than the rest of the nation. And the alpha that we're given is 0.05. So what does this look like? Well, our first question, can the null hypothesis be rejected with the given alpha? And the null hypothesis, we have pi is less than or equal to 0.93, which if this is given, then the town does not have a higher recovery rate than the nation. And then the alternative hypothesis, which pi is greater than 0.93, which the town does have a higher recovery rate than the nation. So our question, if we go back to it, states, does this town have a higher recovery rate than the rest of the nation? Enough to reject the null hypothesis given alpha equals 0.05? Well, what are we trying to find then? We're trying to find that the null hypothesis of the alpha observed has to be greater than 0.05, which is the alpha that they gave us. If it is not, then we fail to reject the null hypothesis. So our problem states that in this town, 19 out of 20 people recovered from this flu. In other words, we have a group of 20 people in this town, 20 random people that we have selected that have been exposed to this flu outbreak. And we want to find the probability that 19 or more of this group of 20 would recover. So how would we set up this equation? Well, we have 19 chosen out of a group of 20, and then we set up with our binomial equation. But then we also have to keep in mind that 19 or more of this group could recover. So we could have 19 out of the 20, but also we want to take in mind that 20 out of the 20 group could recover as well. So we take this probability and add it to the second probability, and then we get an alpha observed of 0.5868. So what does that mean? Well, let's see. Well, this means that we are analyzing this nation has a recovery rate that this nation that has a recovery rate of 93% has a claim that we pick any of these 20 random citizens and there will be a 58.68 probability that at least 19 of them will be recovered from the flu outbreak. So out of this whole nation of 93% recovery rate, we pick 20 random citizens of this town that they claim has a higher recovery rate than the rest of the nation. The probability that 19 or 20 out of those 20 group of 20 random citizens, probability is probably going to be 58.68 that that is actually going to happen. Their claim is actually going to be true. So let's look back at our question. Does this town have a higher recovery rate than the rest of the nation, enough to reject the null hypothesis given alpha equals 0.05? Well, if we look at both alpha observed and alpha, we see that the alpha observed we just found, 0.5868, well, that is greater than the alpha that they gave us, 0.05, so we can conclude that the alpha observed is greater than the alpha. So we now know that since alpha observed is greater than alpha, then the null hypothesis will be rejected in favor of the alternative, that the town does have a higher recovery rate than the nation. What is the second question? What will happen if all 20 out of 20 townspeople are successes? Well, it's the same kind of equation that we set up, except we have a group of 20 out of 20 people. So we do the math and we calculate 0.2342. So our alpha observed is still greater than 0.05. So our conclusion is that the alpha observed is greater than alpha, thus the null hypothesis is still rejected in favor of the alternative that the town does have a higher recovery rate than the nation. Question 3. What is the smallest sample size needed to reject the null hypothesis? The answers to these two questions reveal a lack of statistical power, with a large probability of success and a small sample size. It is difficult to fall below the set alpha number. One option is to increase the sample size. So what does this mean? This means that with a sample size of 20, it is very likely to keep coming up with a number that is going to be greater than 0.05, the alpha given. So we need to find a different number, the smallest number that we can find, to where it will be possible for the alpha observed to actually be less than the alpha in order to reject the null hypothesis. So we can set up the alpha observed less than alpha and set up the equation from the problem that we are given. 0.93 to the n power is less than 0.05, and we can solve this equation using logarithms. And since we're dealing with whole people here, the minimum sample size needed is 42 townspeople to be able to reject the null hypothesis given alpha equals 0.05. Since we found 41.28, we just rounded that up to 42 whole townspeople. In question 4, out of 42 townspeople, how many successes are needed to fail to reject the null hypothesis? Well, how many successes out of the 42 are needed for the alpha observed to be less than or equal to alpha? Well, since we just figured out that 42 townspeople is the minimum number that it's going to take, we know that 42 out of 42 townspeople have to be recovered from this flu outbreak in this town for the null hypothesis to be rejected. This is the minimum number of people that would have to be recovered from this flu outbreak to be able to effectively say that the town having a higher recovery rate is actually a pretty legitimate statement. And if 42 out of 42 townspeople recovered rejects the null hypothesis, then anything less than that would fail to reject this null hypothesis. So that would mean that 41 out of 42 townspeople recovered would fail to reject the null hypothesis, or would not have a higher success rate than the nation. Thank you.